Today we are going to build on what we learned yesterday about our synthetic division. So all the problems that you do today are going to use synthetic division. It just depends on what they're asking you to do to determine how you're going to actually write your answers. So we have two theorems we're going to talk about today. We have the remainder theorem and the factor theorem. The thing to remember when you're doing these is no matter what the question, if they're asking you just to simply divide like they did yesterday, or if they're asking you to evaluate or to determine if something is a factor, you always have to make sure that your polynomial is in standard form before you start doing your division, and you want to make sure that you put any placeholders in if necessary. So the first thing we're going to talk about is the remainder theorem. So what the remainder theorem says is that when you're using synthetic division, the remainder, so the last number in the row, is the value of the function. So basically it's your output, your y coordinate, for the given value, your x. So if you think about if you were going to make a t-chart or something, and you can pick the x values, or if they ask you to evaluate the function at a certain value, you're going to plug that value in, and then whatever the result is, that's going to be the y coordinate. So it's going to create an ordered pair. And if we were going to graph these, which we're not going to do until pre-calculus, but if we were, that would actually be an ordered pair, a point on the graph of the function. So evaluating functions, you guys should recall this. This is just plugging stuff in. So here. So the way that we have always evaluated functions is they're going to give you a function, this is in standard form, and to evaluate it at a certain value. So basically, they're just asking you to plug this in and see what you get. So the way it would look is we would do, instead of f of m, we're going to do f of -4. And then everywhere that we see an m, we're going to put a -4 in its place. And then you just go ahead and figure this out. So remember, this is function notation. The left side here, you don't actually add or subtract this -4. This is just notation. It's the same thing as saying y equals. So my function value evaluated at a -4. So raising -4 to the 4th power, it's going to go to a positive 256. And then if we have -4 to the 3rd power, that's going to be -64. 28 times -4 to the 2nd power, so that's going to be 28 times 16. 21 times -4 will give me a -84, so I'm just going to make this a minus here, plus 19. And then just continuing to simplify, we have our 256. If we do 10 times -64, we get -640. 28 times 16 is 448. Some of you may just go through and plug this all into your calculator. So f of -4, if you plug that all in your calculator, you should get a -1. Okay, so that's our function notation. And remember when we did this before, this right here, this number here, this is basically your x coordinate. This is your input value. And then this here is our y coordinate. So this would create an ordered pair. -4, -1. So that's the old way. That's the way that we used to do it. When you're asked to evaluate using synthetic division, sometimes they call it synthetic substitution because you're substituting and you're using synthetic division to do it. You're going to set up a synthetic division. This right here, if this says m equals -4, you do not have to solve this like you did yesterday. If this is a binomial, If it said like m plus 4 or m minus 4, then yes, you would set it equal to 0 and solve it. But if you see the equal sign, this is the number that goes in the box. So setting up our synthetic division, you're going to put the -4 in, and then you want to check out your polynomial, make sure that you're not missing anything, and make sure you have all the powers in descending order. So I have power of 4, 3, 2, 1, and 0. So that's my constant. So this one is ready to go. We're going to set up our synthetic division, lining up our coefficients. Okay, and then we start by dropping down that first number, and then we're ready to start multiplying and adding. So you're always going to multiply on the diagonal. So this is exactly what we did yesterday. So -4 times 1 is -4. We add our columns. 10 minus 4 is going to give me 6. And then we keep going. -4 times 6, -24. Add these together and we get a 4. Multiply times -4, we get -16. Add the column, we get a 5. -4 times 5 is 20, -20. 19 minus 20 is -1. So this is what the remainder theorem says. So the remainder theorem says that whenever you plug a value in, this here is your x value. The output, or the remainder, that's the y value. That's your y coordinate. So this creates an ordered pair, and the ordered pair is -4, -1. So if we look at the example we did right before, so we can evaluate this way by just plugging in, or we can evaluate this way. And you see we got the exact same answer. So here's my ordered pair. I don't know why that's not changing color for me. Here's my ordered pair, -4, -1, -4, -1. So it's just a different way to do the same thing. I want you to do it this way. We're going to use our synthetic division. If you want to do it this way to check yourself, you can, but this is how I would like to see your work. All synthetic division. Okay, so I just want to do another example for you. This one has some missing powers. So I just want to show you or remind you how we're going to handle those. Okay, so this one, still using our remainder theorem, n equals -4. So again, that's the number that goes in the box. If you see the equal sign, you don't have to solve that. And then this one, we have the power of 3, but we're missing our power of 2. So we have no x squared. So we need a placeholder for that variable. X squared needs a placeholder. So we have n cubed. I guess for this problem, it's n squared, isn't it? Okay, so it needs a placeholder. So we have our n cubed, coefficient is 1. We do not have an n squared, so we're going to put a 0 there. N to the first power is -22, and then our constant, -20. And then you're ready to go. Drop down your 1. -4 times 1 is -4. Add these, we get -4. -4 times -4 is +16. And then we're going to add -6, and then we multiply -4 times -6, and we get a +24. -20 plus 24 will give us 4. The answer should be written as an ordered pair. This is your x, and this is your y. It's actually, once you get good at this, this actually goes quicker than the other type of substitution. And there's your ordered pair. Okay, the next one is the factor theorem. So when we are dividing, again, using our synthetic division, the binomial divisor is a factor of the polynomial if and only if the remainder is 0. So I feel like that should make sense because anytime you're dividing, So if I wanted to take 10 and divide it by 2, well, 2 goes into 10 5 times. But if I wanted to take 10 and I wanted to try to divide it by 3, well, 3 goes into 10 3 times, but we have a remainder of 1. So we would say 2 is a factor because we got a 0 remainder. We would say that 3 is not a factor. So basically, we're going to be doing that synthetic division again, and we're going to be looking for a 0 remainder. So this is how that they'll ask you. It'll say state if the binomial is a factor. So here's my binomial. We want to know, is this a factor of this polynomial? Well, we're going to set up a synthetic division to check it out. They give you the binomial, so this one you have to solve. You have to set it equal to 0, add your 6 to both sides, so n equals 6. So the 6 is the number that goes in the box. And then again, it looks to me like we're missing some stuff here. If we start at the third power, 3, 2, 1, but we don't have that constant, we need a placeholder for the constant. Okay, so don't forget, you have to just have everything, including the constant. Okay, so we have n to the third, which is a coefficient of 1, coefficient of -1 for n squared, -30 for n to the first power, and then we have no constant, so we're going to put a 0 there. And then we just go ahead and do our synthetic division, drop down your 1, multiply. 6 times 1 is 6, -1 plus 6 is 5. 6 times 5 is 30, -30 plus 30 is 0, 6 times 0 is 0, and 0 plus 0 is 0. And when I get a 0 here, it makes me happy because it is a factor whenever we get a 0 remainder. So the answer here, state if it's a factor. Yes, it is. You can't just say yes or no without showing the work, though. You have to do the work for it. Last example for today. So if you look here, this is a little bit of a mess because this definitely is not in standard form, and even our binomial is kind of mixed up a little bit. So we are going to have to take this binomial and we're going to have to set it equal to 0 and solve. Just subtract 6 from both sides. So that's the number that's going to go in the box. I'm not going to set it up just yet because I want to fix this. So the highest power I see is 3. We do have a power of 2, a power of 1, and our constant. So we have everything we need, but it's just in the wrong form, or in the wrong order rather. So we want to put this in standard form. So put your 2x cubed first, your 7x squared next, -35x goes next, and then our constant on the end. So once you put it in standard form, and then once you've solved the binomial, now you're ready to go. So put your -6 in the box. We have nothing missing, so we have no placeholders here. Okay, and then we are going to multiply and add. So drop down your 2. -6 times 2 is -12. 7 minus 12 is -5. -6 times -5 will give me a positive 30. -35 plus 30 is -5. -6 times -5 is another positive 30. -37 plus 30 is going to give me -7. So I did not get a 0 here. This is my remainder. And if you're just stating if it's a factor, if your remainder is not 0, then the binomial that they're asking about, this guy right here, is not a factor. So the answer would be no. So everything you do today is going to be synthetic division. If they ask you to evaluate, your answer is an ordered pair. If they ask you to state if the binomial is a factor, then your answer is a yes or no. If you have a zero remainder, it's a yes. If you have something other than zero, then the answer is no. All right. Let me know if you have any questions. Remember, I'm going to have office hours from 11:30 to 12:30. So you can pop in for questions, or if you need anything, you can always schedule a tutoring session with me. Have a great day.